Okay. Hello, everybody. Good morning-ish. If it's still morning for you, it kind of is for me. We are going to chat today about architecting data science services in AWS. So to kick it all off, I will introduce myself. I'm Hannah. I am a consultant in the data and analytics group as a data scientist at Slalom Consulting in Charlotte. Start back at the beginning, a little bit of how I got to where I am. So I studied math and economics at the University of Richmond, where I also played on the women's soccer team. Why I was there, I saw the movie Moneyball and I was like, oh, this is the thing that I want to be doing. So it was great. I was like, okay, now how do I do this? I graduated from undergrad. I went to NC State and I studied analytics at their Institute for Advanced Analytics, got my master's then, and then went down to Atlanta where I worked at Home Depot's corporate office in their decision analytics group, where I focused on merchandising analysis and sales performance forecasting. Spent about 3 years there, jumped up to Charlotte, and I've been at Slalom for about the past 2 years, working on a variety of projects, anything from EV charging identification models to ad sales. So that's kind of, how I got to this point into this presentation. So we are talking about data science in a changing world. And we are in a really great moment in data science. I think, 10 years ago, we were all sitting there like, I want to do something cool and the world's not ready. And now it's starting to be ready, which is great. We have these high volumes of data. Companies have been collecting their data for a while, and there's more, and it's better, and it's accessible. And everyone's spending a lot of time making it that way so that it's useful. Stakeholders are now asking really good questions. They really want a lot out of their data. They want a lot out of their people. And they really want to use these modern techniques. They're not arguing about R squared anymore and linear regressions. They like XGBoost, neural net, optimization, all of these things that we sit and we're like, oh, I want to do it. Now we can. And that's so much fun. And then we have cloud. And these cloud services give us so much power to answer these questions and use this data and create infrastructures which can process the big data we're now working with and to make the insights available to stakeholders. And that's kind of created this modern data science environment where we're not just building models anymore. They're now asking us to build models and engineer the data to get it ready for the models and architect these infrastructures that make it really accessible for the people and optimize all of this so that it's the best and it's cost effective and it's useful and it works. And so it's more than just how good your model is. It's also about making it accessible and keeping it valuable for the business. And it's those two pieces that are kind of create a data science service. You have data science and then you have the bigger picture. And that is really important now because the world is changing for our customers too. I'm going to kind of preface the case that we're walking through. This is really the only point where I'm going to talk about what the actual problem was we were digging into, because the point of this conversation is not, okay, what is the problem we answered and did we answer it? It's how did we create this environment that makes the answer available to the people we were answering it for? So we are all turning towards a much more digital environment. We are putting on video on demand when we're ready to watch a show. We're flipping through our phone. We have all the social medias. We have our cable boxes, which is the traditional route. Some of us don't have our cable boxes anymore. So the companies that create the advertising in these different channels have to think about the full thing now. It's not just, okay, what time do I play this during the football game? It's, okay, how do I reach the people who watch the football game, but also the people who are going to watch The Bachelorette on demand on Tuesday night because they missed it on Monday. So those are two different methods of advertising, believe it or not. And so we were asked to kind of bring those worlds together. These companies have been thinking about them in two different kind of parallel streams for so long, and they wanted to bring it into one look, which takes an optimized budgeting kind of thought. And so that's what we were asked to do, was to create an optimized budget kind of recommendation engine for multi-channel advertising. We needed to predict customer exposure. We needed to test a solution set because they didn't know all of the inputs. They were just wanted to figure out what the best ones were. And then we needed to make that into a self-service tool that the business could access, because they didn't want to send us all their options and have us do it and then come back and that. They wanted to be able to put in their inputs to get an answer right away. And so there's the data science part, which is what we all love and we love to think about and love to work on. But then there's the other 4 pieces of this puzzle, which is how do we make all of the work that we've done useful and valuable and accessible and updated and all of these things. And so we have to be efficiently collecting the data. We have to get it from all of the different databases and data sources and all of that to where we can use it. Then we have to, the model and optimization bit, which, is the one that's fun to talk about, but that's actually the one we're almost comfortable with. So that's not the most interesting thing, I think, in this lineup here today. There's the stakeholder accessibility part. There's, retraining and the automation of that, because there's always more data and there's always more information and everything gets more informed when you can pull that all in. And then there's making it easy to update, because you don't want to be scared to have to change a line of your code. You want it to be as painless of a process as possible. So to start, data intake, we all know that bad data leads to bad insights. Good data leads to better insights, because sometimes it's just an impossible situation. But you can set yourself up the best for success when you set yourself up with the best possible data. And we have big data. We all have big data these days. Transactional data, millions of rows, hundreds of gigabytes to work through on maybe even a daily basis. And you think about 2 years, 3 years, 10 years, it's massive. Merging different data sources, like I had said, in this problem, there were different kind of sources and they were all being brought together. And so there were different business habits around this. There was different date formats. The commonalities to bring it all together were scattered across DIM tables. And so we needed to figure out how to get all of this into one spot, and one spot that we could use it. And so we use these awesome ETL tools that, AWS has created for us, Batch and Glue and S3, to hold data throughout the process, but also to hold the data at the end so that it's then in the whole Amazon cloud world for us to use for all the other steps. And then also secrets manager for Glue and Batch to hit, because best practices mean you don't put that information anywhere anyone can get to it. And so that's how we are referencing those logins to get to those databases. But this is kind of the first piece of the bigger puzzle, is how do we get all of this data into one spot? And this was our solution, and it's working great. There's the model and the optimization piece. So the challenge of this, like I've said before, was we had some set inputs, we had some unset flexible inputs. We needed to, provide a recommended value for the flexible inputs. We have this model that we created that, takes one set of inputs and recommends that customer exposure, but we also have to test it across a variety of options because we don't know what the inputs really are. And then we need to return back the best option. There's also the processing of what that best option is. And there's, reference tables that need to be found to create inputs and all of these things. But just for training, that's kind of the easier part in this case, but you have to think about it larger than that. So we have S3, again, the one from just before that has our training data in it, and it's sitting there with our reference tables. We have Lambda, which was our solution to run our Python script on top of the model, to run the model, but also to run the optimization piece that looks at all of the different model outputs. We have this great addition to Lambda from AWS in the last year, which is the fact that you can now use a Docker image and host that in ECR and have your Lambda, link up to that and have this much larger environment. Previously, it was like 262 megabytes, which was not enough space to have both an XGBoost model and to be able to read all the files in the different formats, That was the problem we were running into. So this solved and made this all possible, which was awesome. Thanks, Amazon. And so we have that. And then this all kind of fits together, SageMaker and training pulls the data from S3. It sends the model back to S3 for that Lambda to reference. And then Lambda has the whole environment that we created for it in the image, in the container image. And then we also, you start with developing and testing. We had some notebooks that sat on top of EC2 instances, and that's kind of our little playground to figure out how exactly this was all going to go until we put it into the larger, kind of more structured environment. And then the really important part, I mean, we all know that having a good model is a really important part, but it's also not very important if people can't use it. So the stakeholder accessibility piece was crucial to our service that we were providing and our product for our client. And that was something that needed to be super available to the business users. And it also needed that, validation step on the inputs and custom error response to tell them what was wrong about their inputs if they were wrong. And then also the reference tables and the model information. And so we're starting to see the merge of some of the pieces from before as these kind of stack on top of each other to create this larger service that we're building today. And so Amazon API Gateway is our kind of window into our data science and data world that we have sitting back there. The users over there on the far right, they hit Gateway. Gateway hits the Lambda. Lambda used the container that we've created, and it goes to S3 to get all of this model and reference table information to create the inputs and validate the inputs, and then runs the models and returns the response to API Gateway, which sends it back to the user. And so now we have this access point that the consumers have to get their answer back when they want their answer, which removes emails to us randomly throughout the day when we're working on a lot of fun and other interesting problems, unless we have to go fix it because it's broken. And then there's the other pieces that are time saving and important to keeping everything working and updated and modern. And that's, this first one is automated retraining. So there's always new data, more useful data. It needs to be integrated into the training data, so the model is using as much as possible to kind of, create itself in the training process. This also takes a lot of time to update this data. Trust me, this is complicated. This takes a lot of time. And so we really just want this to be as kind of sidelined as possible. It's something that you look at and you observe, but you don't have to click through line by line. You just go in if something goes wrong. And so we have, there's our glue and our batch and our SageMaker and our S3, the pieces that we've already kind of constructed as part of this. And now we're introducing Airflow as our scheduling mechanism, which is great because it connects to all these pieces and says, go. Airflow says, glue, go, run your ETL and batch. And we have some Python notebooks that run just straight from Airflow because that's the best way to do that. And that's actually what kicks off the hyperparameter training, because we don't need to make it more complicated than that. And so now all of these pieces and everything that lands in S3 and is sitting there waiting for the Lambda is up to date. And it's up to date on a process that's scheduled monthly, that just kind of operates in its own kind of living, breathing environment with just oversight from us instead of, constantly being on our minds. And now we can turn our attention towards developing other projects and other questions that the business is asking, and we can be useful to them in both kind of the maintenance and also further development of work. And then there's this last piece, which for me, I don't know about the rest of you guys, is terrifying. And that's when you have to change something. It can be, a date format changes from dashes to slashes or slashes to dashes. And now a filter's broken to, actually changing modeling steps or the type of model or data locations and stuff like that. That means you could potentially break everything by doing that. And there's so many pieces. You've seen all these pieces that we've built. If you had to manually pull them down and put them back up, that would take forever. And so we really wanted to create an environment and an architecture where this update process was not terrifying, where it was seamless and it was painless, and it was something that was really easy to work through. It also needs to be as well documented as possible, because then you can pass it off to other people. You can transition it to the business. You can transition it to another team member without spending hours, on knowledge transfer or being worried about calls in the middle of the night, in the next month when something goes wrong. And then there's also limiting manual processes, just eliminates chances for human error. there are a lot of points where it is the better decision to have a person who makes the final decision, and there's some where it just isn't necessary and it takes time away that could be spent elsewhere. And so our solution for this, and the little floating AWS glue at the top there, is CloudFormation and Code Build. So these are two services that AWS has that create these kind of automated rebuilds and configuration saves that keep everything up to date and looking the same, or make updates very, very structurally processed through a structured process that you don't have to, are going to work. They work the same. They go through, and usually if they fail, it's because you missed a comma or a quotation mark or something like that, which are much easier to just edit that one CloudFormation template than to have to worry about the rest of everything. And so this is what keeps all of our pieces up to date and in the right configurations and everything operating and referencing the right spots. And so we have CloudFormation templates that create code build jobs, one of which keeps our S3 and our Airflow up to date with the code development we're doing, which is saved in Git. We have CloudFormation template, which creates all of our glue jobs, which references the files that we have saved in S3. And also the templates for all of these CloudFormation templates are saved in S3. And then we have a code build job, which creates the Lambda and the API gateway and the ECR image, the container image, and updates that and keeps those all connected so that our API environment is living and breathing and its own kind of space there, not connected to anything else, so that we can control when it is and isn't kind of rebuilt. And so the big picture of all of this, we have all of these things that are sitting there in our AWS account that are talking to each other that make this possible. The CloudFormation templates store all these configurations for the various services. Airflow does the monthly run and keeps the data up to date. The glue and the batch reference scripts that are in S3 that our code build job keeps up to date, which is just kind of this circle of information, and everything, stays current. And then we have that code build, which creates our Lambda and our API and our image when we need to update all of that, which we've created to be manually part of the process so that we can, use business judgment to make that decision, because sometimes the computer shouldn't make the decision. It should be the person. And so that redoes all of those pieces so that the user, then is hitting a new model. If the model's better, if we've improved on that with the most recent training job. And so all of these infrastructural pieces come together to create this service that is very available to the business side, that is using the most recent data, that is up to date, that is not something that's terrifying to update. And, when small changes or big changes, if your database changes, it's pretty easy to kind of make those tweaks and those adjustments and keep moving forward. And that is kind of the end of all of this. I mean, we have built this system now for our business to use. It's now, in our case, it's live and it's working and it's great. And I'm able to kind of tackle the next question, which is really cool. If you have any questions, let me know. I am on LinkedIn. You can find me there. There's my Slalom email. You can email me also. Slalom itself is hiring. So if you're interested in that, feel free to reach out. We can chat, or I can connect you with someone, or you can go to the Slalom website and they can do that. But we have 40 seconds left. If anyone has any questions, feel free. Otherwise, it was great talking to all of you guys today. I hope that this was fun and useful and, gave you some ideas. Also happy to hear ideas from you. If anyone's worked through something like this and has something that they know works and is awesome, let me know. Excited to hear anything. So thank you guys for your time today.